Good day, everyone. I am Joseph of Digilytic Solutions. I am a consultant, trainer, speaker, and a book author. Welcome to our course, Mastering Machine Learning Algorithm. In this course, we will learn about analyzing beta density function. At the end of the lesson, you are expected to identify the concept of beta density function, compare the shapes of the beta density function, appreciate the roles of beta density function in machine learning. In our last lesson, we learned about the uniform density function. We said that it is the most basic form of continuous probability distribution. We said that it is rectangular. We discussed that it has a constant probability that tells that each range of values which has the same length on the distribution has equal probability of happening. We learned that the two-step process, first is getting the value of the height of the rectangle, and the second is defining the multidimensional random variables. If you missed lesson number 9, the link is given in the description below. You may pause this video and come back when you're done with it. This makes lesson number 10 more meaningful. You are given this question. How likely is it that Donald Trump will win the next presidential election? So you may tell me that the probability is 0.3. So if you ask your sister, she might say that it's 0.18, and somebody might think it's 0.25. The beta density function offers you the way to describe this kind of problem. So first, maybe you would like to ask me, what is a beta density function? So this function, beta density function, can be used for continuous random variables that are restricted between 0 and 1. This is a function of two parameters, A and B. So this kind of distribution is only defined for theta, which can be sometimes represented by R or X, or you can choose any letter if you want to, depending on the user, lying on the range of 0 and 1. Also, beta density function represents a family of probabilities, and this is a versatile way to represent the outcome for percentages or proportions. So our next point to consider is that how is it defined using mathematical statements. So this is the formula in solving for the beta. So this statement represents the beta density function. So what's the meaning of the symbols here? So maybe sometimes you would get intimidated if you just look at this one at face value. Okay, we will have this one by one. So this symbol, can you see this one? This and this one, okay, so they are the same. So they represent, or this represents the gamma function. The beta, okay, this is the second parameter in the density function. This one, the A or the alpha, is the first parameter in the density function. So this one, the beta, then times alpha and beta again. So this acts as a normalizing constant to ensure that the area under the curve of the probability density function is equal to 1. So as you can see, this definition includes both ends. The first one is 0 and the last one is 1. So this makes it consistent with the other definitions of continuous, which are supported on a bounded interval. So another notable characteristics of the beta function is that it is used to specify prior knowledge about the probability of something occurring. And we can also specify a large range of beliefs by changing the parameters A and B. So for better understanding, let's have this statements. Supposing A is equal to 0.5 and B is equal to 0.5. So we can say that the probability of theta given a and b is proportional to theta negative 1/2, 1 minus theta negative 1/2. And if we're going to graph the outcome of this statement, then we could see that the shape is a U shape. And maybe you would like to ask me, why is it that negative 1/2 is here and negative 1/2 is here? So it's very simple. Let's go back first to this one. So remember that this is alpha minus 1, and the value of our alpha is 0.5. So that is 0.5 minus 1, and the answer is 0.5 or negative 0.5 or negative 1/2. And also with this one, still the same. So we have here beta minus 1. So the value of our beta in the problem is 0.5, and when we do the subtraction, the result is negative 0.5 or negative 1/2. Okay, now let's change some values to make this story more interesting. What if alpha is 0.5 and by this time our beta value is 1? What could be the result? So we can say that the probability of theta given a and b is proportional to theta negative 1/2. And maybe you would like to ask me, why is it that we only have 1/1/2 here? Where is the other one? So remember that this is 1. So when we deduct this by 1, then this becomes 0. So the value of beta cannot be considered anymore because it's already 0. And what matters most now here is that this value. Okay, this value. This value. Okay, so that's why we have 1 over theta 1/2. And the shape of the distribution is like this. Okay, so here the second term is 0 because b, which is 1 minus 1, is 0. And if you're going to graph, the shape is like this, just like a slide. So it's going to be asymptotic at 0, but it will never be symmetric like the first one. But if we're going to switch the values of a and b, the shape will flip, of course. So assuming that the value of a here, alpha, is 1, and b here is 0.5, of course, the shape will flip. It means it will be like this. Okay, so that's the illustration of the flipping of the values. So if a is 1, for example, and b is 1, then we can say that the probability of theta given a and b is proportional to the constant. So why is it constant? So it would be constant 1 across the range between a and b, or the probability would be constant 1 across the range because a and b are all 0. So see, remember? So let's go back to this one first. So this becomes 0, this becomes 0, 0, 0, right? And then we have the constant 1, and what remains is the constant, which is 1. Okay, remember here? So what remains would be only 1. Alright, so if we're going to graph this, then the shape is a straight line. Okay, so you can see here, so this is the graph of the third situation or scenario wherein a is 1 and b is 1. So you can see just a straight line. So it means that we are going to get a sort of a uniform density distribution. Remember our uniform density distribution wherein we get a rectangular shape? So it's something like this. There is a uniformity of the distribution from 0 to 1, across 0 to 1. So this is going to be at values 1, and the area integrates at 1. So having all these scenarios, we can arrive at some interpretation of alpha and beta. So we can think of a minus 1 as the number of successes, and B, or the alpha, the beta, as the number of failures. So you can choose alpha and B or beta parameters however you think they are supposed to be. Okay, you have the freedom to choose. Okay, for example, if you think the probability is high, let's say for example it's 80%, set 80% for alpha, and that means 20% for beta. So of course, if you choose otherwise, it is possible, but then again, the outcome will be different. As A becomes larger, the weight of the distribution shifts towards the right. It's like this one. It's going to the right because alpha now is now 1. Okay. So, and then, if we are going to increase the value in beta, it moves the distribution towards the left. Okay, like this one. Okay. Okay, so that increases going to the left. That is if you're going to increase the value of beta. Okay, so this is the best example of this one. So if we increase both the values of alpha and beta, the distributions become more pointed towards the middle. So it's like this. It becomes pointed and then pointed. The more we increase it, the more it becomes pointed at the middle. So until the point wherein we know alpha and beta become infinite, which is delta function at the value 1/2. So they will be accumulated in a center and pointed going up, and that becomes an infinite value going up. What is this for? Why do we have to study this? It is most commonly used in machine learning in modeling the uncertainty about the probability of a success of a given experiment. So after all being said and done, let's try this. What is a beta density function? What is the effect of varying the values of A and B? What is the use of beta density function in machine learning? Do not forget to subscribe, like, and share. Please click the bell button to be notified every time we have a new session. See you in the next lesson.